Hello everybody and welcome to another episode of Math with Mr. Emond. Today we're going to be continuing our unit on radical expressions and equations. This is lesson 4 where we're going to be looking at dividing radicals, and today we're basically just going to be focusing on performing multiple operations on radical expressions, rationalizing the denominator, and then finally solving problems that involve radical expressions. So let's get started. So let's start off with some easy stuff. Let's gain some confidence before we go and delve into the harder stuff. When you divide radicals, you divide the coefficients and then you divide the radicands, okay? So you divide the coefficients and then you divide the radicands. So what does that look like? Let's look at this first one here. First, you can only do this if they have the same index. And this is kind of where I'm kind of hinting that once we don't have the same index, it gets kind of tricky. But it's okay, because we have the math skills to pull through. So let's do the easy ones first. Let's divide the coefficients here. What's 4 divided by 2? Let's just start by doing that. 4 divided by 2. Let's move it under one radical. 4 divided by 2, and we're going to divide the radicands here. So we're dividing the coefficients, and then we're dividing the radicands. What's 4 divided by 2? It's a tough one. That's 2. And then on the inside of the radicand, we have 6 divided by 3. Ooh, that's also 2. 2 cube root 2. That was a tough one. All right, let's do the next one. We have the same index here. Again, we're going to put it under one radical here. And we're going to have 18 divided by 3. And we're going to have x cubed divided by x. Okay? Let's review what to do with exponents when you're dividing them. So first off, let's visualize. What is x cubed? That would happen to be x times x times x is x cubed. And if you divide that by x, well, hopefully you've learned what to do here. If you have like things on the bottom and the top of the denominator, you can cancel them out. So what are you left with there? You're left with x squared. Okay? Let's actually do this the algebraic way, which I prefer because I like algebra. Algebra makes sense, and once you know it, things become super easy. So the algebraic way is, let's do something a bit more difficult. Let's do x to the power of 7 divided by x cubed. Okay, well, we could draw it out like that. That's not preferable, though. When you divide things that have the same variable, so x, for example, or this could be a 6, right? We're going to do that over here. 6 to the power of 7 divided by, why did I put a 3 there? Oh, it's because it's cubed. Divided by 6 cubed. Okay, x7, 6x cubed. Well, the algebraic way of doing this is that when you have the same variable and different exponents that are getting divided, it's x to the power of 7, which was the first one, minus 3. So what you're left with is x to the power of 4. And you can check it, if you don't believe me, 1, 2, 3, 4, 5, 6, 7. If you don't believe me, you can do this, right? 1, 2, 3, and then you can cross them out. These are gone, and these are gone, and what's left? 4x's, x to the power 4. So you see, this does work, okay? And this is an important skill to have, is to be able to work with exponents here. So what would this one be? This one would be 6 to the power 4, right? And we can check that one. This one is a bit easier to use in your calculator. 6 to the power of 7. Oh, nope. Divided by 6 to the power of 3 is that. And let's just check what's 6 to the power of 4. Oh, look at that. They're the same thing. So it works, okay? And it's going to be very useful for you. So when you have x cubed divided by x, you just do 3 minus this exponent is a 1. 3 minus 1 is 2. So here we have the square root of 18 divided by 3 is 6, and x squared. Excellent. We did it. This was an easy one too. Reviewing this, don't forget it. We're going to use it in a slide or two when things start to get a little tough. But for now, let's stick with the easy stuff. It's your turn. Pause the video. Come back in a couple minutes to check your work. I'm going to resume the video in 3, 2, 1. Here we go. Let's check your answers. 6 divided by 3 over 12 divided by 6 is 2 root 2. Here we got negative 24 over 8 divided by the cube root of 14 over 2. Negative 24 over 8 is negative 3. Cube root 14 over 2 is 7. Excellent. That's the easy stuff. Let's move to the stuff that you're in pre-calc for. Here we go. Picking up the difficulty. Rationalizing the denominator. What this is a process. And in this process, what we're trying to do is eliminate the radical from the denominator. Why? Remember in lesson 1 when we said one of the rules of a simplified form is you cannot have a radical in the denominator. We don't like that in math. So we're going to get rid of it by not changing the answer. And whatever a teacher says, I'm going to eliminate something by not really changing the answer, it means we're going to multiply by 1, or we're going to do some other trick to get rid of it. And in this case, we're going to multiply by 1. But it's not going to be 1. It's going to be root 3 over 3, which is 1, right? Something divided by itself is 1. Okay, good. Let's do it. We have 5 root 3 divided by 2 root 9. I could also write this as 2 root 3 squared, right? And that's because using previous knowledge, we're going to cancel these out. What is this? This is 5 root 3 over 2 times 3. Oh, look how that worked out. We got rid of the radical in the denominator. Now we have 5 root 3 over 6, and you're good to go. It's rationalized. Everything makes sense. Let's do the same thing over here, except, oh no. Look at our indexes. This one has an index of 2, and this one has an index of 3. Oh, things are about to get fun, okay? Remember in lesson 1, we said that radicals are similar to exponents. In fact, they're exponents where the exponent is a fraction. So this can be rewritten as 2 times 5 to the power of 1/2. Now, if you don't remember this, go back to lesson 1 and review it. I said it would be important later. This is when it becomes important. And let's do the denominator here. 3 times 6 to the power of what? It's a cubic function, 1/3. Okay, let's think about how are we going to rationalize this. I'm just going to take this. I'm going to move it here because I want a bit more space because I'm going to rationalize it. Now, when I rationalize it, we have a root on the bottom. We don't want a root on the bottom, so we are going to have to multiply by something. Let's look at exponents again. If I have 6 to the power of 1/4, which is not what we have here, right? I'm changing it just a little bit so we can redo it over here for fun because math is fun. And so I have 6 to the power of 1/4, and I want to multiply it by something to get rid of our fractional exponent. And when you multiply it by something that's the same, right? Same variable, what happens to the exponents? They add together. That's right. And what do we want them to add up to get rid of it? Well, that would be 1. So 1/4 plus what is 1? 3/4. Okay? When you multiply these together, they are going to equal 6 to the power of 1 plus 3 is 4/4. And that would be 6 to the power of 1, which is just 6. Everything disappeared. Now, I want to also kind of take a minute to appreciate what 6 to the 3/4 mean. Let's look at this. Let's make sure we understand what that means. Remember that if you have 6 to the 1/4, what was that? That means it was a 4th root of 6. You remember that? Converting back and forth between these? So if you have 6 to the 3/4, what does that mean? Well, it's still this, except on the inside here, it's cubed. So it's 6 cubed, 4th root. Look at that. If it's 6 cubed and it's the 4th root of that, what is that? 6 to the 3/4. Okay? So let's just, we're just kind of reviewing some things with exponents right now. All right. Here we go. We have 6 to the 1/3. What are we wanting to multiply to make it equal to 1? 6 to the 2/3. Okay. What you do on the bottom, you must do on the top. Okay. Let's move to the next step. 2 times 5 to the 1/2, which, remember, this is just the square root of 5. Let's not forget that what this means. This means the square root of 5. It's not crazy, right? And then times 6 to the 2/3. And remember what this is it's the cube root of 6 squared, meaning the cube root of 36, okay? So it might look freaky and scary, but it's not, okay? They're just a different way of writing radicals with exponents. Okay, let's look at the bottom. We have 3 times 6 to the 1/3 times 6 to the 2/3. When you have the same variable or base multiplying different exponents together, they add together. What's 1/3 plus 2/3? It's 1, or 3/3, right? 6 to the 3/3, which is 1, okay? What's 6 to the power of 1? What's 6 to the power of 1? It's 6. You just got rid of it. Isn't that beautiful? What's 3 times 6? It's 18. I'm just trying to save some space here, okay? Because it's going to get a little lengthy. It's 18. 18. It's beautiful. We cleaned it up. Let's rewrite this. We have 2. Let's change this back to the square root of 5. Okay, we're just going back and forth here. Let's do this one too. We have the cube root of 6 squared. Let's change this. Let's expand it fully. Instead of 6 squared, it's 36. Okay. And finally, we have 18. I'm going to do something. I'm going to change 18 to 2 times 9. Why did I do that? It's because I can see the future. I can see that I have a 2 here and a 2 here. And remember, just 5 minutes ago, we said when you have something on the top and the bottom that's similar, right? You can cancel them out. Well, aren't those two things that we just did there similar? Yes, they are. So what can you do? Cancel them out. Let's cancel them out. They're gone. We eliminated them. And here's our final answer. This is what I'm going to stick with. And that's not a 0.9. I just want to be clear. That's a 9. Okay? We have root 5 times root 3 of 36 over 9. Let's get a little crazy here. Let's check our answer. I don't know why anybody would ever want to do that in math, right? Let's try 2 root 5. And we're going to divide this. And I'm just putting parentheses because I want to make sure my calculator is going to do the right thing. We're going to divide that by 3 cube root of 6. Let's see what the calculator says. It says 6 to the 2/3 times root 5 over 9. Oh, okay. Okay. I like my answer better. Okay, they're the same thing, right? 6 to the 2/3 is this, right? 36 is what? 36 is 6 squared. It's under cube root, which means it's 6 to the 2/3. So this is the same thing. This, we're gonna say 6 to the 2/3 times root 5 over 9. We got the right answer. Are you scared yet? You should be. Let's try this. So here we're rationalizing the denominator, but this time we're going to do something that is kind of fun. It's called multiplying by the conjugate. So this is another little trick that you can do to get rid of things. Multiplying by the conjugate literally just means we're going to take this negative sign and we're going to make it positive. So we had 4 minus root 6, now we have 4 plus root 6. Remember, what you do to the bottom, you must do to the top. And at this point, we're going to have to do your favorite thing, foiling. Okay? Foiling the top, foiling the bottom. And let's get to work. What is 5 root 3 times 4? 20 root 3. What is 5 root 3 times root 6? That would be 5 root 18. Okay? Let's look at the bottom. What's 4 times 4? 16. What's 4 times root 6? 4 root 6. What is negative root 6 times 4? Minus 4 root 6. And what is negative root 6 times root 6? Well, that would be negative root 6 squared. Okay? Let's see what happened here. Why did we do this? Why don't you look right here? What's 4 root 6 minus 4 root 6? 0. 4 root 6 minus 4 root 6 is 0. So in the denominator here, you now have 16 plus 0. And when you have a square and a square root, what did we say happens? They cancel out. So this just turns into minus 6. So this whole bottom denominator just got massively simpler because all you have left is 16 minus 6, and that's 10. So your denominator is now 10. Let's rewrite this. You have 20 root 3 plus 5 root 18. And actually, before we go any further with this one, we can simplify this 5 root 18, right? Because 5 root 18 is 5 times 9 times 2. And this is, oh, my pen's not working, there we go. And this is 3 squared, 9 times 2. And we can pull out this 3, right? So 3 times 5 is 15 root 2. There we go. We simplified it up a little bit more. And the denominator was 10. Easy. Maybe. All right. Why don't we do some more? Because I bet you some of you are still doing a little bit of head scratching and you need a bit more practice. So we're going to do just a little bit. Whoa, I'm drawing everywhere. We're going to do just a little bit more practice here. Make sure that you got this covered. Let's look at this first one. What would you do? Yep. Rationalize. So you're just going to get rid of the root 3x. Okay. So we're going to multiply our tops now. What's 24 times 3? 72. What's x squared times x? X cubed. Okay. Let's do our bottoms. What's 3 times 3? It's 9. What's x times x? X cubed. Here we go. Why in the world did we do that? It's because of this. 9 is actually 3 squared. And now we have two things that are squared on the bottom. So this turns into, we can probably rationalize the numerator. Or not rationalize it, but simplify it. But we're just going to leave it like this for now. We're going to deal with the bottom. We can pull both of these things out, right? So all we're left with is 3x. Awesome. Let's look at the top. We can definitely work with this. Okay? we are going to do, let's look at our numbers. 2 squared is 4, 9, 16, 25, 36. That's the one I wanted. 36 into 72. So we're going to do 36 is 6 squared. And then we're going to have x squared and x. Right? X squared times x is x cubed. Why did we do that? It's to simplify it. So this, we're going to be able to remove this 6. We're going to be able to remove this x, right? And all we're left with on the top is root x. And on the bottom we have 3x. Things just got even better because 6x divided by 3x is 2. It's 2. The x's cancel out. 6 divided by 3 is 2. So our final answer is 2 root x. Wow. We got from this all the way to that. That's some simplifying. Okay. Let's do this next one. What are you going to do? Multiply by the conjugate. So root 5 minus 7. You just flip the sign. Okay? Root 5 minus 7. And let's get to work. On the top we have 11 root 5 and negative 77. 11 root 7 minus 77. On the bottom you have root 25 and negative 49. Root 5 squared and negative 49. I'm missing some. I'm missing a lot. I'm also missing, I'm missing this one and I'm missing that one. We also have, that and negative 7 root 5. And we also have plus 7 root 5. Oh, I probably, why did I do that? Plus 7 root 5. Okay. Now, the whole reason why we rationalize the denominator is to do this. These cancel out. This simplifies, right? So you have 11 root 5 minus 77 on top. And on the bottom, this is gone. This simplifies down to 5 minus 49. I want a little bit more room here. So we have 11 root 5 minus 77 over 5 minus 49 is negative 44. And we have simplified. Okay. 2 more. Let's do this one. Oh, this one's nice and easy. Look at that. You know what? We could have simplified this one too. This one's nice and easy. Okay, 4 divided by 3 is 4/3 and 5n over 2. That didn't really work that well. Let's rationalize. You see, sometimes it's better to use one method over another. So let's multiply by root 2 over 2. What does this equal? We have 4 root 10n over 3 root 4. Okay. This is going to simplify down this one here, 10n. No, it doesn't simplify. So 4 root 10n. I meant the top doesn't simplify. The bottom does, right? And 3 root 4. Root 4 is 2, right? So this is just 3 times 2. 3 times 2 is 6. Finally, we can reduce these. This is 4/6. We can reduce it to 2/3. So 2 root 10n over 3. Where instead of 4/6, we change it to 2/3. Just reduce it down. There we go. Simplified form. Okay. Let's do the last one. rationalize the denominator again. Oh, they are different. Okay. This is a square root, this is a cube root. So we're gonna do some more fun stuff. So to get rid of this one, you're gonna multiply by 6 to the power of, this is 1/3, right? Hopefully you can visualize, this is 6 to the exponent of 1/3. So we're gonna multiply by 6 to the exponent of 2/3. To the top and the bottom. Okay. Now we have 4 root 11. I'm going to scroll down. 4 root 11 times 6 to the 2/3 divided by y times, and what's going to happen here is they're going to cancel out, right? 6 to the 1/3 times 6 to the 2/3 is 6. That's why we did it. So finally we have 4 root 11 times, I'm going to do the cube root of 36. And 6y. I'm looking at this and this, and I'm seeing I can reduce those. 4/6 is 2/3. Okay? 2/3. And I'm done. Let's go to your turn. Give it a shot. This is where radicals start to get a little tough. You're going to need to practice, okay? Exponential functions are also quite important for dealing with radicals. It does help. It helps a lot. Give it a shot. Pause the video. I'm going to show you the answers in 3 seconds. 2, 1. Here we go. Okay. 6 divided by 7 root 5, you rationalize the denominator. When that happens, you simplify down to 6 root 5 over 35. This doesn't really get reduced anymore. Okay. Let's look at this. You are going to multiply by the conjugate, and then you're going to FOIL. When you FOIL, you're going to eliminate some terms, and you end up with this. Good. Let's do this one up here. 2 plus root 2 over 3 root. You're going to multiply by the conjugate, right? Whenever you see a binomial down here, you're going to multiply by the conjugate. So eliminating those middle ones, this is going to simplify out, so there's no radical. 45 minus 16 is 29. This is a whole mess, but it doesn't matter. Why? You can't combine them, and you can't combine them, you can't combine them. It's no big deal. That's the answer. Thanks everybody for watching my video. If you liked it, please support it by hitting that like button. You can hit subscribe right here. I appreciate the support. And you can find future videos in the playlist right over here. And of course, the next one in the series, just click this link right here. See you next time. It's Mr. Emond. Bye-bye.